The table below examines the values of a to the h take 1 divided by h for various values of a as h approaches 0. Complete the table, rounding your values to 5 decimal places. Okay, so the first gap we have here, so what do we got to do? We've got to do 2.70, that's our a value there, to the power of 0.1, which is the h value over here, and divide that by 0.1. If we do that, we get 1.04475. And then we just need to repeat that for the other boxes, which seems a bit tedious for 2 marks, but you shouldn't be able to really get it wrong, which is great. So the values we get 1.00113, 1.03015, 0.99326, and 1.00064. What is the exact value for a for which d dx of a to the x is a to the x? Well, think about it, you know this. d dx of e to the x is e to the x. It's the function that differentiates to itself. Explain how the above definition and the table in part A support your answer. Well, the value itself is a is equal to e, which we can say is approximately 2.71828. In fact, I don't need an approximate if I put the ... there, do I? Just goes on forever. Now, I really don't like the answer that's in the mark scheme for this, because I don't think they really use the table. The most relevant value in the table for us is this one here, because that's the closest value of a to e and the smallest value of h. And if we look at this, what we're after is where the limit as h tends to 0 of a to the h take away 1 over h, we want that to be equal to 1, and then d dx of a to the x is equal to a to the x. The fact that this value here, when we're closest to e, is 1.00064 really shows that we're close to 1 there, and we could intimate that if the a was a bit closer to this value and the h was smaller, that this would be closer to 1.